Okay, this is problem number 3 on set 20B. Pretty typical problem. We've done a lot of these, I think. We'll remind some stuff. So the question says, we got some data which I actually graphed. It came in a chart. It was the time in hours that this water was flowing out of a pipe and how many gallons per hour. It's fine. So the first question said, use a midpoint Riemann sum with 4 subdivisions to approximate the interval from 0 to 24. So 0 to 24 is just area under curve. We haven't done a midpoint one before. We've done one of the trapezoidal, which is the average of the left and the right. So they said 4 subdivisions, so 1, 2, 3, 4, which is going to allow 3, 9, 15, and 21 to be my midpoints. I'm going to use the midpoints for the heights of the rectangle. So each rectangle has a width of 6. So there's my 6 there. And then the 4 heights I'm going to use are the 10.4, the 11.2, the 11.3, and the 10.2. So I'm just multiplying the width of each one of those rectangles by each one of the heights. Add them up, I got 258.6. And the other question was, what does that measure? Like, what does it mean? So remember, we're integrating rate, which means we're going to get total water, right? So 258.6 gallons is the amount of water that's leaked out in 24 hours. Part B says, is there some time where the derivative equals 0? Justify your answer. So if you notice, we have 9.6 here, we got 9.6 there, excuse my scale. Draw that secant line. Remember that we have the mean value theorem. The mean value theorem says if a function is continuous and differentiable, which they told us it was at the beginning, that whatever the slope of that secant line is, there has to be a parallel tangent line also. So I just said yes, because those 2 points are 9.6, which means the slope between them is 0. And by the mean value theorem, there guarantees a derivative equaling 0. And the last part of that question is just the rate. It can actually be modeled with a function instead of points like this. And this is the function, and then same basic question. It's not the exact same question, but basically the same thing that says, find the average water flow during the 24-hour time period. So remember, average is just integrate the function over that time period and then divide it by the length of the interval. So I just did this straight on the calculator, nothing else. And I got 10.78. So it's the average rate, so it's 10.78 gallons per hour. So I think that's it for number 3.